In this session, we are going to talk about when is the function monotonically increasing and when is the function monotonically decreasing. To understand this, first I'll just plot a graph, and from there we'll derive each and every concept of this monotonically increasing and decreasing functions. So let's take the graph of y equal to x square. So let's take some values of x and plot the graph. Say x is equal to -3, -2, -1, 0, 1, 2, 3. Corresponding value of y, I am plotting it. Y is 9, 4, 1, 0, 1, 4, and 9. So we substituted the x coordinate here. We got the corresponding values of y. Now I am going to plot the graph. X-axis, y-axis. Here 0, 1, 2, 3. Here -1, -2, -3. Now the value, let's take this as 10. This is 5. Now let's put the approximate values. When x is -3, y is 9, somewhere here. When x is -2, y is 4. When x is -1, y is 1. And 0. Then again 1. It says 1, y is 1. 2, it is 4. 3, it is 9. So if you plot it, we get a curve like this. And we call this curve as parabola. Now what you notice is, as the x values are increasing, the y coordinate is also increasing. Which means, whenever I take two neighboring points, let's say x1 and x2, imagine x2 is greater than x1. So let's imagine this is x1, this is x2. x2 is greater than x1. What do you look at the y coordinate? Here this much is the y coordinate, here this much is the y coordinate. You will notice that the y coordinate at x2, f of x2, will be always less than f of x1. If this is true for all points in that particular interval, then we say the function is monotonically increasing. So when the x coordinate is bigger than the other x coordinate, corresponding y coordinate is bigger than the respective y coordinate, then we say the function is monotonically increasing. Let's have a look at this one. Here you can notice that -2 is greater than -3. -2 is greater than -3. But whose y coordinate is more? The y coordinate of -3 is greater than y coordinate of -2. So what is happening here is reverse. When the coordinates are bigger, the function values are lesser. Such case we say function is monotonically decreasing. For example, here let me take this as x1 and this as x2. Which is greater? x2 is greater than x1. But f of x1 is greater than f of x2. So such case we say the function is monotonically decreasing. So we can say that in this case, from -infinity to 0, the function is monotonically decreasing, and 0 to infinity, the function is monotonically increasing. So this is how we calculate how monotonically increasing and decreasing. So I'm going to give you how will we apply derivative to decide whether the function is monotonically increasing or monotonically decreasing. Another word for monotonically increasing is strictly increasing. If you use the word strictly or monotonically, both means the same thing. Now we will check how we will apply this apply derivative to decide when is the function increasing and decreasing. So I have 2 points. One is x, another is x plus h. Remember, h is a greater number. H is a positive number. So x and x plus h, which will be greater? X plus h will be greater than x if it is monotonically increasing. So if f of x is monotonically increasing, then we have noticed that x plus h is greater than x because h is a positive number. So f of x plus h will be greater than f of x. So naturally f of x plus h minus f of x will be greater than 0. I divide both sides with a positive number. So f of x plus h minus f of x upon h is greater than 0. And we are talking about very close neighboring points. So we can put h tending to 0. So when a function is monotonically increasing, you will notice that the definition of the derivative dy by dx will be greater than 0 at that point. So whenever a function is monotonically increasing, the derivative will be positive. So f dash of x will be positive. So if I want to check whether the function is monotonically increasing, just find the derivative, check where the derivative become positive. Wherever the derivative become positive, those places the function is monotonically increasing. Same way, decreasing, it will reverse in sign. So in case of decreasing, it would be like this: x plus h is greater than x, but f of x plus h will be less than f of x. Hence, this part would become negative. Hence, f dash of x will become less than 0. So the dy by dx will be less than 0 when a function is monotonically decreasing. So this is all we have to remember. Checking whether the function is increasing or decreasing, find the derivative. If the derivative is positive, then the function is increasing. Derivative is negative, function is decreasing. We can also interpret this in another way that I am going to show you now. This is the axis. This is the curve. What you notice about this curve? Is it monotonically increasing or decreasing? As the x coordinate increases, the y coordinate is increasing. So this curve is monotonically increasing. So if I draw a tangent, let's say tangent at a point, this angle theta, everywhere you notice, whether I draw it the tangent over here or tangent over here, everywhere theta is going to be acute. So tan theta will be positive. Tan theta is positive. Remember, tan theta is nothing but the slope of the tangent. So slope of the tangent is positive. So for an increasing function, derivative will be positive. This is also another way of interpretation. Let's have a look at the function when it is decreasing. Let's say this is a decreasing function. Now if I draw a tangent at any point, what is happening? The tangent will make obtuse angle. It will be an angle more than 90 degrees. So naturally when the function is decreasing, the tangent will make a obtuse angle with the x-axis. So the slope of this tangent will be tan theta, which will be negative because theta is in second quadrant. Thus tan theta will be negative, which means the derivative will be negative. So this is also another way of interpretation. So slope of the tangent at this point in an increasing function will be positive, and slope of the tangent for a decreasing function will be negative. This is also a technique to interpret that when derivative is positive, the function is increasing. Derivative is negative, the function is decreasing. Now we will apply this in the problems. When it is monotonically increasing, the derivative should be positive. When I say a function is monotonically decreasing, the derivative should be negative. So I calculate the derivative. So f dash of x is 3x squared minus 6x plus 3. So I found out the derivative of the function. Now I see 3 is common. So 3 is x squared minus 2x plus 1. This is a perfect square. So 3 into x minus 1 whole square. So you know that square of a number is always non-negative. So this will be greater than or equal to 0 when x is 1. So I can say the derivative of this function is non-negative. So I can say from here, f of x is increasing for all values of r, for all x belonging to r. So nowhere the function is decreasing. So everywhere the derivative is positive. Hence we can say the function is increasing for all values of x. Now let's have a look at the function f of x equal to minus x plus 1 by x. I want to know whether this function is increasing or decreasing. So I'll find the derivative f dash of x. Derivative of minus x is minus 1. Derivative of 1 by x square is minus 1 by x is minus 1 upon x square. So I can write this as minus 1 plus 1 by x square. You can say this is a positive number, all the values of x. So what I can say this function is derivative is always negative, less than 0. So f of x is decreasing for all x belonging to the domain. So why did I use the domain? Because x is 0, the function is not defined. So all other values than x being 0, the function is decreasing because the derivative is negative. In this particular function, we are asked to check for what values of x, what should be the values of x, where the function, for which the function is increasing and the function is decreasing. We are interested in finding out what should be the domain, in which part of the domain the function is increasing and which part of the function is decreasing. So as usual, I start with the function f of x equal to x cubed plus 12x squared plus 36x plus 6. Now I find the derivative f dash of x. That is 3x squared plus 24x plus 36. Now I take 3 common. So 3 into x squared plus 8x plus 12. Now this can be factorized. 6 and 2. So 3 into x plus 6 into x plus 2. That is, I did the splitted 8x as 6x plus 2x and then factorized it. Now what I can say, I need to find out where the function is increasing. So I will draw a number line. Mark the point where this becomes 0. X plus 2 becomes 0 at minus 2. X plus 6 becomes 0 at minus 6. Remaining points you need not mark. Now what we'll do is, we'll do the sampling. We'll find out in which region the function is positive and which region the function is negative. So what do you mean by sampling method? Take one sample point, substitute and see what is the value of the function. So I'm going to put a number between minus 2 and infinity. 0 is a number between minus 2 and infinity. So I'm replacing x by 0. So when I replace x by 0, what calculation do I get? I get a positive calculation. 3 into 6 into 2 is a positive calculation. So I will say minus 2 to infinity, it is increasing. So positive sign. And minus 6 to minus 2, negative sign. If this region is positive, this region will be negative, and again this region will be positive. Automatically it works. So first what I did, I took one sample point and substituted and saw. I saw that what value I'm getting is positive. Then its neighboring region, it will be negative. Its neighboring region will be positive. It works alternatively. So I can say the derivative is positive from minus infinity to minus 6 and minus 2 to infinity. And the derivative will be negative from minus 6 to minus 2. So my conclusion, f dash of x is positive, is greater than 0, if x belongs to minus infinity to minus 6 union minus 2 to infinity. In this region, the function will be, the derivative will be positive. That is, in this region, f of x is increasing. Now, you can see from f dash of x will be negative in which region? If x belongs to minus 6 to minus 2, the function is less than, derivative is less than 0. Therefore, f of x is decreasing in this particular region. So the function is increasing in minus infinity to minus 6 union minus 2 to infinity, and the function is decreasing in the remaining part of the region. So this is how we can find out. So it's very simple. Take the function, find the derivative, find out the points where the derivative becomes 0, mark those points on a number line, then take one value anywhere you feel like. You can even take a value in between here also. Suppose I put value as, let's say, minus 4. If I put minus 4 here, I'll get minus 2. If I put minus 4 here, I'll get plus 2. So I'll get the product to be negative. So this region is negative. If this region is negative, its neighboring region will be the opposite sign. So it will be positive. So we can calculate very simple way where the function is increasing and decreasing. Now we need to check, we need to find the value of x for which this function is decreasing. So I'll take the function f of x is 2x cubed minus 15x squared minus 84x minus 7. I need to check where the function is decreasing. So I need to check where the derivative is negative. So decreasing word can be replaced by where the derivative becomes negative. So f dash of x became 6x squared minus 30x minus 84. If I take a 6 common, x squared minus 5x minus 14. Now this can be factorized as x squared minus 7x plus 2x minus 14. So 6 into x minus 7 plus 2 into x minus 7, which I can write 6 into x minus 7 into x plus 2. Now what I should do? Now draw a number line, infinity, minus infinity. Where does this become 0? At 7. Where does this become 0? At minus 2. So the derivative becomes 0 at 7 and minus 2. Now tell me a number between minus 2 and 7. 0 is a number between it. So if I put x as 0, so the calculation would be 6 into minus 7 into 2. it gives you a negative value. So that means in this interval, the derivative is negative. So in this interval, the function is decreasing. So my conclusion is f dash of x is less than 0 if x belongs to minus 2 comma 7, open interval minus 2 comma 7. Hence f of x is decreasing. We wanted to find the function is decreasing. F of x is decreasing from minus 2 less than x less than 7. This becomes my answer. So the derivative is decreasing in the interval minus 2 to 7. Now find the values of x for which this function is decreasing. So we start with f of x is equal to x raised to x. Now first of all, remember this function is defined only if x is greater than 0. The function is not defined, so the domain of the function is greater than 0. Then when you find the derivative of f dash of x, you know base and power are functions of x. Derivative is done by taking log. So y is equal to x raised to x. Log y is equal to x log x. Then differentiated 1 by y divided by dx is x into 1 by x plus log x. So dy by dx is y into 1 plus log x. We are supposed to know this by heart. X into 1 plus log x. So I can say f dash of x is x raised to x into 1 plus log x. We want the function is decreasing. This is always exponential functions are positive functions. So f dash of x is decreasing when f dash of x is less than 0. So I have to find out what values of x the derivative become less than 0. That is x raised to x into 1 plus log x is less than 0. So 1 plus log x is less than 0 because x raised to x is always positive. So log x should be less than 1. Base of the log is e and minus 1. So x should be less than e raised to minus 1. So base of the log went to the base of the right hand side. So I can say x value should be less than 1 by e. And we know that x is greater than 0. So my conclusion is f of x is decreasing from when x belongs to 0 to 1 by e. So the function is decreasing in the interval 0 to 1 by e. You need to find the interval in which x upon log x is increasing. So f of x is equal to x upon log x. So f dash of x will be denominator into derivative of the numerator minus numerator into derivative of denominator upon square of the denominator. So that became log x minus x into 1 by x upon log x the whole square. So I can write log x minus 1 upon log x the whole square. So that will be the derivative. So derivative of the function is log x minus 1 upon log x whole square. Remember, this is always positive. So the function is increasing. So we need to find out where the derivative is greater than 0. So f dash of x is greater than 0 if log x minus 1 is greater than 0. That is log x is greater than 1. Remember, x is a non-negative number, x is greater than 0. So x should be a number greater than e raised to 1. That means the function is increasing. So f of x is increasing in the interval e to infinity. This will be my final answer. So the function is increasing when x takes value from e to infinity.